For completeness, we'll test both CDP-based and range-based network discoveries. Let's begin by exploring the run_discoveries.py script. The import statements don't introduce anything new. We need JSON to read data from a file, time for request pacing, OS for creating directories, and our DNA Center SDK for general API operations. Let's start with the main function. We'll see this code in almost every script, which authenticates to the DNA Center reservable sandbox. I won't dwell on it again. In order for discoveries to work, DNA Center has to log into our devices somehow. At a minimum, we must provide CLI credentials along with SNMP version 2 read and write communities. Using a simple for loop, we issue an HTTP GET request to collect each type of credential. The credential subtype key is specified using query parameters via the params keyword argument. Because the sandbox only has one of each credential by default, we can safely index the first element in the list, then extract the ID. Here's a JSON callout that shows the credential structure, and ultimately, we want to share the credential ID. We'll add it to the cred list and print a status message indicating so. Next, we load in our discoveries from a file named discoveries.json. Let's quickly explore that file. This is a list of dictionaries where each dictionary represents the HTTP body of a post request used to start a discovery. First, we run an IP range-based discovery named globo_IP. I've specified a small range so the discovery runs quickly. Next, we run a CDP-based discovery named globo_CDP, which starts at a single IP address. The CDP level option bounds the diameter of the discovery, and in the interest of time, I've specified one hop. Once loaded, we iterate over the list, updating each dictionary with the credential list from earlier, which must be specified. Then, we invoke the run_discovery helper function. As you probably guessed, these discoveries can take a while. We'll wait 600 seconds or 10 minutes by default. First, we start the discovery with a post request using the dictionary from the JSON file as the HTTP body. The response from that API call is shown in the callout, and we'll use the task ID shortly. Next, we wait for the discovery creation process to complete and capture the discovery ID. We'll need that ID to query the discovery status later. Here's an example of what the response structure looks like for those interested. Now, we begin a for loop that runs 60 times by default. First, let's query the status of our specific discovery by specifying the ID in the URL. Then, from the response shown in the callout, we'll extract the response dictionary and store it in the data variable. If the discovery condition is not complete, print a status message with that condition and sleep for 10 seconds. This indicates that the discovery is still running. Otherwise, the discovery has completed, so mark success as true and break from the loop. If success is still false, that means that the loop completed without the discovery finishing. Raise a timeout error to signal this failure. In order to collect data from the discovered devices, we'll create new subdirectories for each discovery in the disk output parent directory. First, get a list of all discovered network devices, then iterate over that list. Here's what the data looks like, and there's a ton of technical detail here. If the devices are reachable, that indicates DNA Center can log in to the device. We can indicate success with a status message. Additionally, if the device is already in the inventory, we can issue a follow-on GET request to collect even more data about the device. Here's what that data looks like for comparison, and you can explore the dumps in the data ref directory. The output file will be a 2-key dictionary where the topmost keys are discovery and device. The discovery key contains the discovery results, while the device key contains inventory-specific device details. This dictionary gets dumped to an output file in the proper subdirectory created earlier and is named using the discovered hostname. If a specific device is not reachable, print a status message indicating the reason to assist with future troubleshooting. Let's clear the screen before testing our code. Now, we can run the discovery script using the command shown, which may take several minutes. After about 7 minutes, it looks like everything worked, so let's scroll up to the top. First, the IP range discovery found 5 devices. The discovery ID was 210, and we should have a new subdirectory with that ID in our disk output directory. Then, the CDP discovery with ID 223 took much longer to run. At the end, it discovered 3 devices, one of which is inaccessible using the DNA Center credentials. Let's see the high-level results using the tree command. Within each directory, we see all of the discovered devices based on hostname. Let's check out leaf 1 within the 210 subdirectory. First, the discovery subdictionary contains the information returned by the discovery process. The device is reachable via ping, SNMP, and CLI, and its management IP address is revealed. The follow-on device collection goes far beyond discovery and provides additional details about the device. We won't scrub this data as I think you get the point. Let's wrap up the module in the next clip.